Good morning students, myself Sachin Goyal, I am your chemistry teacher. Welcome to Noske Public School, Sri Ganganagar e-learning platform. So we will start with the chapter electrochemistry for class 12 today. See, electrochemistry, this chapter deals with the electrical conduction in solutions. As far as conceptual target is concerned, this particular chapter is an extension of redox reactions what you have read in class 11. So starting with this chapter, the topic as it says, it starts with electrochemical cells. Electrochemical cells, you know, they are a source of electrical energy. An electrochemical cell is a device that converts chemical energy into electrical energy by the help of a feasible redox reaction. To start with, we will start with the topic which you have already studied in class 11 in redox reactions. It was rather the last topic in the redox reactions, and it is the first topic in this chapter. So, we will start with a typical electrochemical cell called the Daniell cell. Okay, so this diagram is about a typical electrochemical cell called the Daniell cell. If you look at the construction of this cell, it consists of a zinc rod, a copper rod, a beaker containing 1 molar aqueous solution of zinc sulfate and a beaker containing 1 molar aqueous solution of copper sulfate. The copper rod is immersed in this copper sulfate solution, whereas the zinc rod is immersed in zinc sulfate solution. So what happens here is, zinc is more reactive than copper, it is more metallic than copper. So what happens is, as this half cell, this particular part is called a half cell, this half cell comes in contact with this half cell of copper, electrons transfer from the zinc rod to the copper rod. Okay, and what happens here is, the zinc rod starts disintegrating. We can write this half reaction as zinc solid gives zinc aqueous ions plus 2 electrons. And what happens on the other end is, this solution contains copper ions. So as the electrons accommodate and accumulate on this copper rod, the copper ions present in the solution readily accept these electrons and get reduced to form copper metal. So we can observe here that in this half cell of zinc, oxidation takes place. So we call it oxidation half cell. Whereas reduction takes place in the copper electrode, and this is called reduction half cell. But to maintain the electrical conduction, we have a salt bridge which contains any aqueous solution of ionic compounds such as potassium sulfate or potassium chloride in a matrix of gelatin. The salt bridge maintains the electrical conduction. So when electrons flow from the zinc rod to the copper rod, they pass through any device which you can connect in this circuit, and this circuit can use this electrical energy. As you know, moving electrons is what you call electricity. So in this way, an electrochemical cell generates electricity. Electrochemical cells can be of various types, like the dry cell or the Leclanche cell, which we normally use in toys, torches, etc. They can be small cells such as mercury cells you use in watches. They can be these Daniell cells, we usually use them for demonstration purposes in laboratory. They can be very huge structures such as fuel cells, which are used by astronauts in space stations. So it has massive uses. You can see here that a redox reaction has taken place and a feasible redox reaction has taken place here. Feasible means which can happen easily. This happens here because zinc is highly reactive as compared to copper. So electron flows readily from zinc to copper. So looking at these things, we can come to certain conclusions here. Number one, since the electrons flow from zinc to copper, we can justify that we can give a negative sign to this electrode, as there is accumulation of electrons or the generation of electrons or excess of electrons, what you can say here. On the other hand, on the copper rod, there is lack of electrons. That's why there is a transit of electrons from zinc to copper rod. Number two, what you can do is you can classify them as anode or cathode. Anode, by definition, is that electrode in any type of cell in which oxidation takes place, and cathode is that type of electrode on which reduction takes place. So here what happens is that, as you can see in this cell, oxidation has taken place on the zinc electrode. So you can call this rod as the anode, whereas this half cell can be called as the cathode, as reduction has taken place here. Number two, you can give the cell reaction. The cell reaction would be written as, looking at the anode, zinc solid gives Zn2 positive aqueous ions plus 2 electrons, and on the cathode, copper ions have accepted electrons to give copper solid. So what you do is, the cell reaction is given as the addition of these two half reactions after balancing the number of electron transfer. So you cancel out these electron transfer and then you add both these half reactions to get zinc solid plus copper ions aqueous gives zinc ions aqueous plus copper solid. Moreover, you can give the cell representation. The cell representation is given as Zn solid slash Zn2 positive aqueous double vertical lines Cu2 positive aqueous slash Cu solid. The ionic concentration is also expressed here along with the particular electrode. So zinc ions we have taken as 1 molar. So you can specify it here as 1 molar, whereas the copper ions are also 1 molar in this case. So you can specify it as 1 molar. So in this way you calculate the cell representation, the cell reaction, the anode and the cathode. After this, one important thing you can conclude is the standard cell potential, which is given as the standard electrode potential of the cathode minus the standard electrode potential of the anode. Here the standard electrode potential of copper is 0.34 volts, whereas that of the anode, that is zinc, is minus 0.76 volts. So this Daniell cell generates a potential difference of 1.1 volts. What this electrode potential is, we will learn about in the next video.